Hey everybody, I hope you're doing well. In today's lesson, I want to talk about antiderivatives. Antiderivatives are derivatives going backwards. I'll talk about a power rule, a constant multiplier rule, a sum rule, but I won't be talking about a product rule or a quotient rule today. In fact, there is no product rule, at least it's not done like that for antiderivative. There's a technique called integration by parts, and we will not be covering that in this class. So what is an antiderivative? An antiderivative is a function whose derivative is the function that we actually want to get to. What does that all mean? Well, let me jump into some stuff here. So an antiderivative, let me talk about notation. There's a lot on this page, I understand, and I'll go through it piece by piece. So an antiderivative is denoted by a capital letter. Now, that's tradition. So if I have a little f, the antiderivative is a capital F. If I have a little g, the antiderivative is denoted by a capital G, and so on. So what is a property of an antiderivative? Well, if I take a derivative of an antiderivative, I get back the original function. So for example, 2x plus 3. An antiderivative, there could be more than one, is x squared plus 3x plus any number that we choose. I can choose 7, 5, pi, -3. It doesn't make a difference here. So my question is, why is capital F the one I have written down? Why is that the antiderivative of that? Well, that's where these little properties come into play. If I took the derivative of this, I use a power rule, I use a constant multiplier rule, and I use a constant rule. The derivative of x squared is 2x, the derivative of 3x is 3. And that's the original function that I have. And, well, it's independent of what this last number is, this constant. So here's a second example, and this is actually a much harder example. Suppose I give you, and I won't give you this is a verification process just to show you what antiderivatives can look like. If little f of x is x times sine of x, then I claim that an antiderivative for this, remember I said an antiderivative, not the antiderivative, because there's more than one, is sine of x minus x times cosine of x. Well, why is this the antiderivative of this? I should have said an antiderivative. So why is it true? If I took the derivative of this, I would need to use the product rule, trig rules, and a power rule, because I have an x sitting in there. So what is the derivative of sine of x? Well, that's cosine of x. Minus, well, what's the derivative of a product? Well, it's the derivative of the first times the second plus the first times the derivative of the second. Derivative of cosine is negative sine. So now simplifying this, I see that the cosines are going to cancel. This minus sign here, that's going to make this a plus, and the outcome is x sine of x. So the antiderivative of x sine of x is this particular function here. Now, I'm asking you to verify these things. I am not asking you how to determine an antiderivative from the function here. I am not showing you a technique at the moment to go from here to here. I am simply saying that I claim this is the answer, or an answer, for an antiderivative of 2x plus 3. And I'm also saying sine of x minus x cosine of x is an antiderivative for x times sine of x. So in other words, how can I actually come up with some rules for antiderivatives? We have a whole bunch for derivatives. In other words, if I gave you a function, how do you actually come up with this piece or this piece? So to do that, let's do a quick little recap of some derivative rules. We have the power rule. Drop the power, subtract the 1 from the exponent. The constant multiplier rule. In other words, the constant comes along for the ride. The sum rule. The derivative of a sum is the sum of the derivatives. Some of these, well, these three translate very, very nicely to the antiderivative situation. So an antiderivative rule, a power rule, I want to do the opposite of this. Instead of multiplying by an old power, I want to divide by a new power. Well, what do I do to the power over here? I subtract 1. What's the opposite of subtracting 1? Adding 1. So what we get here is I am going to increase the power by 1. So that exponent is n plus 1. And I'm going to divide by the new power. So I'm dividing by n plus 1. Now, when we divide, we have to be really careful that we do not divide by 0. So I have to remove the case where n is equal to -1, because if n is -1, I get a 0 in the denominator. So while the power rule works for any exponent that I want under differentiation, this power rule has a limitation. We can't have that power as a -1. In other words, 1 over x does not follow this pattern. There's a separate rule just for that. That's why antiderivatives are a little harder right off the bat. There's a special case in here. The constant multiplier rule, well, that's as easy as it is for the derivative rules. In other words, if I have a constant times a function, the antiderivative is that constant times the antiderivative of the function that we were looking at. Now, I put this in here just as a reminder because I said it before. There is no simple product rule. In fact, we're not even going to talk about integration by parts. That's the non-simple product rule that I referred to earlier. The sum rule. The antiderivative of a sum is the sum of the antiderivatives. So that's a very nice rule. So here's an example. So let's see if I can walk through this example. Suppose I give you x cubed plus 3x plus 1. The sum rule says I can treat 1, 2, 3, those 3 individual parts separately. Let's work with x cubed. X cubed is a power. I'm going to increase the power by 1 and divide by the new power. Increase the power by 1, divide by the new power. Well, that simplifies to the x to the 4th over 4. Now what about the 3x? Well, I'm going to use the constant multiplier rule. The 3 is going to come along for the ride. Now I have an x. That's the power rule, and the original power here is 1. I'm going to increase the power by 1, divide by the new power. X squared divided by 2. I'm going to rewrite it like this. 3 over 2 times x squared. What about the 1? Well, the power involved with that is 0. X to the 0 is 1. I'm going to increase 0 by 1, and I wind up getting x to the 1st divided by 1. Well, I'm just going to write that as an x. Now, this last little part. Remember, the derivative of a constant is always 0. So this little part, it can be any number that we want. It could be a 12, it could be a pi, it could be a 32, it could be a 42. Anything goes. In a later video, I'll talk about how we can use this unknown to answer some other questions that we'll be looking into. I hope this short video was helpful, and if you have any questions, send me an email. Have a great day. See you later. Bye.